Some more important statements. Theorem, the inclusion, exclusion rule for 2 or 3 sets. If A, B, and C are any finite sets, then the cardinality of union of A and B is the cardinality of A plus cardinality of B minus the cardinality of their intersection, and the cardinality of the union of 3 sets is the cardinality of first set plus the cardinality of the second set plus the cardinality of the third set minus the cardinality of their intersections pairwise plus the cardinality of their intersection. We are using these formulas to write probability of union between 2 sets or 3 sets. So basically, as you remember, the probability of A union B is the probability of A plus probability of B minus the probability of A intersection B. And in the case that the intersection between A and B is empty, or A and B are mutually disjoint, this guy is equal to 0. But from the second relation, the probability of A union B union C is the probability of the first set plus the probability of the second set plus the probability of third set. And then you're going to subtract the probability of their intersections and finally add the probability of A intersection B intersection C. Let's take a look at one example together and feel more comfortable about this. A professor in discrete math class passes out a form asking students to check all the math and computer science courses they have recently taken. The finding is that out of total of 50 students in the class, we have the following observations. 30 took pre-calculus, 18 took calculus, 26 took Java, 9 took both pre-calculus and calculus, 16 took both pre-calculus and Java, 8 took both calculus and Java, 47 took at least one of the 3 courses. Note that when we write 30 students took pre-calculus, we mean that the total number of students who took pre-calculus is 30. And we allow the possibility that some of these students may have taken one or both of the other courses. If you want to say that 30 students took pre-calculus only and not either of the other courses, we will say so explicitly. Very good. How many students did not take any of the 3 courses? Well, take a look at our calculations. By the difference rule, the number of students who did not take any of the 3 courses equals to the number of class minus the number of students who took at least one course, which means that 50 minus 47, which is 3 students. So 3 students didn't take any of the 3 courses. Part B, how many students took all 3 courses? That's an interesting case. So suppose P represent the set of students who took pre-calculus, C, the set of students who took calculus, J, the set of students who took Java. By inclusion-exclusion rule, we know that the cardinality or the size of the union between P and C and J is n of P plus n of C plus n of J minus the cardinality of the intersection between each one of these pairwise plus the cardinality of all of these intersections. Very good. So first of all, note that we know you have 47 who took at least one of these 3 classes. So when we say at least, it means that you have the union between these 3 sets. The number of people who took pre-calculus is 30. 30 took pre-calculus. The number of people who took calculus, 26. Okay, I think it flipped this. So it took, let me just fix this to avoid any confusion for you. So let me just erase this one. Okay. There should be just, okay. It's a little bit out of order, but that makes sense. The number of people who took calculus is 18, and the number of people who took Java is 26. Beautiful. Okay. So the number of people who took pre-calculus and calculus at the same time, both calculus and pre-calculus, it is 9. And then the number of people who took pre-calculus and Java is equal to 16. Very good. And then the number of people who took calculus and Java is 8. And we don't know how many students took all of these 3 courses together. So that's why it is missing. We're going to do a little bit of algebra. If you do algebra here, 47 minus the rest of these addition and subtraction, 6 people took all of these courses. So far, so good. Now, let us take a look at the last question. How many students took pre-calculus and calculus, but not Java? How many students took pre-calculus, but neither calculus nor Java? Very good. From the information that we calculated in part A and part B, we know that if we look at the intersection between pre-calculus, calculus, and Java, the intersection, as we did the calculation in previous slide, is 6. Well, we know 3 students didn't take any of these courses, so that's why you see a 3 down here. Very good. So the number of people who took pre-calculus and Java, take a look. Pre-calculus and Java is 16. And at the same time, 6 of them are in the center. They took 3 classes. So you're left with 10 that took Java and pre-calculus. The number of people who took, let's go to the next one, pre-calculus and calculus. Pre-calculus and calculus is 9. So 6 of them are in the center here, took 3 classes. So you're left with 3 students who took pre-calculus and calculus. And finally, Java and calculus. The number of people who took Java and calculus is 8, but 6 of them are in the center, took 3 classes. We already have them. So you're left with 2 students. So again, 6 is the number of students who took all 3 courses. 3 is the number of students who took both pre-calculus and calculus, but not Java. So that's how we can visualize this and do the calculation when it comes to inclusion-exclusion formula. So now that we did the calculation and we filled out these circles, since the intersection between pre-calculus, calculus, and Java is 6, put the number 6 inside, which is the intersection with all of these 3 circles, and do the calculation. For example, since 9 students took both pre-calculus and calculus, and 6 took all 3 classes,